With that little bit of practice that we did on evaluating absolute value expressions, we're now ready to learn how to solve absolute value equations. So that's the I can statement for section 2.2. I can solve absolute value equations. So go ahead and write the word equations there, and then we've got a little bit of warm-up here, and hopefully you remember what these are. So the first one is absolute value refers to the blank a number is from 0. And remember, absolute value refers to distance. That's why absolute value makes that, whatever that expression is inside, positive, or whatever that number is positive, because distance is always positive. So absolute value refers to distance. Please don't forget that. And then yesterday we found two numbers whose absolute value was 6. What numbers are they? Now, if you remember yesterday, or look at your notes or something like that, you can find those in there. But we can also think about it this way. If their absolute value was 6, that means both of them were 6 units away from 0. Well, those numbers that were 6 units away from 0 were -6 and +6. Okay? So those were the two numbers that had an absolute value of 6 from yesterday, or absolute value of 6 yesterday. So when we're talking about absolute value of a number, the absolute value does not care which direction the number is from 0. It only cares about how far it is from 0. So it doesn't care which direction it is. It can be to the left or to the right. What it cares about is how far is it. Like in this one, we wanted an absolute value of 6. It needed to be 6 units away from 0. So we care about how far it is from 0, not which direction it is when we're talking about absolute value. Now, if we know that and understand that, then we can rewrite this question up here as an equation. So we really want to be good at solving equations. And that's what we're going to do today. We're going to solve absolute value equations. So the way we would rewrite that question up here is we would say something like this. Question mark in absolute value is equal to 6. So the absolute value of some number is equal to 6. And we're going to take a look at how we can solve that on a graph. So this is example 1. We want to solve this absolute value equation, and notice that I've replaced the question mark with an x. So what we're asking here is the absolute value of x equals 6. So what this is saying is, it's asking this question. Where does x need to be so that it is 6 units away from 0? So I'm going to put 0 right here. And then the question is, where does x need to be so that it's 6 units away from 0? Well, the answer is we can either be 6 units in this direction, and x can be right there, or we can be 6 units to the left, which would put us at -6, and x can be right there. So what that means is there are two answers to this. One of them is x can equal -6, and the other one that x can be right here at +6. And remember, the whole point of solving an equation is to get a number that makes the equation true. So if we were to put -6 right here, the absolute value of -6 is 6, so that would make the equation true. And if we were to put a 6 right there, the absolute value of 6 is +6, so that would make it true. So I've got a box right here because when we're talking about solving absolute value equations, it's really important that we remember a couple of things. And so here we go. With very few exceptions, there are always two cases to an absolute value equation. We'll talk about what those exceptions are in a few minutes, but that kind of begs the question, why are there always two cases? Well, the reason there are two cases when we're solving absolute value equations instead of just getting one answer like we did with a regular old equation is because there are two directions. And as you can see up above, we went 6 units to the right and we went 6 units to the left, and we got those two answers. We got one on the negative side and one on the positive side. So one case is going to be the direction going to the left or going in the negative direction, and the other case is when we go to the right or go in the positive direction. So I'm going to change this just slightly, and we're going to have a little bit more complicated equation here. So we're going to solve the absolute value equation. The absolute value of 2x is equal to 10. So this equation is basically asking, when is 2x 10 units from 0? So again, let's look at this on a number line so we can kind of figure out what's going on here. I'm going to put 0 right here, and we need to be 10 units away from 0. This problem has something to do with this expression being 10 units away from 0. Well, one way that we can be 10 units away from 0 is we could go down here to the left. So we could go to -10. Another way that we could be 10 units away from 0 is we could go to the right 10 units. So when is 2x 10 units away from 0? Well, 2x could be down here, or 2x could be up here. And then we've got two equations that we can solve. One of those equations would be 2x is equal to negative 10, and the other equation would be 2x is equal to positive 10. And then we just solve each one of those. So we're just going to divide by 2. So I get x equals negative 5 on this side, and then I divide by 2, and I get x equals positive 5 on this side. So again, we've got two answers here, and here's why both of those make it true. If I were to plug in a negative 2, this would be, sorry, a negative 5. This is 2 times negative 5. That would be negative 10. The absolute value of negative 10 is 10. That makes that equation true. Same thing over here. If I were to plug in a 5, I get 2 times 5, that would be 10, and the absolute value of 10 is 10. So again, just to kind of demonstrate here, 2 times negative 5 in absolute value, that would be negative 10. Whoops. Negative 10 in absolute value does equal 10. And then the same thing would be true here. Absolute value of 2 times 5, does that equal 10? We've got a 10 over here in absolute value. Is the absolute value of 10 equal to 10? And the answer there, yes it is. So both of those check out. If we plug those into the original equation, we do get a true equation. So when we're solving absolute value equations, it's going to come down to this basic process. Once we isolate the absolute value, and that's really important, I want you to underline that. We are going to need to isolate that absolute value expression. Whatever that absolute value expression is, we need to isolate it. Then we're going to break it into two cases. One for the negative side. Okay, one for the negative side, in other words, going to the left, and one for the positive side, or going to the right. Okay, so I've got some steps right here. So when we're gonna solve an absolute value equation, the first thing we're gonna do is we are going to isolate the absolute value. So whatever that absolute value expression is, we want to isolate it. Then we're going to break it into two cases, and then we're going to solve those two cases. Now, I've got this breakout box right here to talk about those cases. The first case is we're just going to remove the absolute value and we're going to solve the equation. So that's really easy. We just literally take off the absolute value. And the other one is a little bit tricky, and we'll talk about why we do this. We remove the absolute value and we make the number the opposite of what it was, or the negative of what it was, and then we solve it. Okay? So let me show you, we've actually done this already. So I want you to notice up above on this problem right here. This was an isolated absolute value expression and it was equal to 10. So what we did is we took the absolute value off, which just leaves us with 2x, and set it equal to 10, and then we solved. We got this answer right here. You'll notice on this side, when we went to the left, when we went to negative 10, we take the absolute value off and we make the number the opposite of what it was. So when we do this opposite part right here, this represents the fact that we're going to the left, okay? So I'm going to go through, and it's not nearly as complicated as it might seem. It's actually pretty easy, okay? Now, I do want you to take note of this. This means that we're almost always going to get two answers to absolute value equations, and we're going to point out the exceptions to that. Remember up above we said there are always two cases, so we're usually going to get two answers. I'm going to point out the exceptions to that right now. So we're going to solve this equation right here. And again, I've got a graph here to kind of demonstrate. Once we've got this isolated, this is asking where does x need to be so that it's 4 units away from 0? Well, there are two ways to do that. We can be over here at 4, or we can be over here at negative 4. So x can be either right here or right here. So one of the answers is x equals 4. It's just like removing that absolute value right there and then solving, which x is already by itself, so we're all set. The other case would be remove the absolute value and change that to the opposite sign, and there are our two answers to that problem right there. Now, that's a very simple one. They are going to get more complicated, so don't draw too many conclusions from this. Let's take a look at this one right here, and I've got asterisks by each one of these because these are the exceptions. So this one is saying where does x need to be so it's 0 units from 0? So if 0 is right here, where does x need to be so it's 0 units from 0? Well, it needs to be right on top of there, okay? So the answer to this, if we follow this little technique, it does actually work here. So remove the absolute value, It's already solved. Now, if we remove the absolute value and set it equal to the opposite of what it was, there is no such thing as negative 0, okay? So these two would represent the same thing. It's right on top of 0. The only way it can be 0 units from 0 is if it's right on top of there. Now, if we take a look at this next one right here, this was where it gets really interesting. This is saying, where does x need to be so it's negative 6 units from 0? Now, this is a negative. And remember, absolute value is a distance, so it's always going to be positive. So this side is saying it's going to be positive. This side is going to be negative. I guess the smallest this could ever be would be 0, but that's still not negative. There's no way those two things are going to equal each other. Okay? So this positive would never equal a negative, and if we get something that's never going to be true, of course the answer is no solution. Okay? So the answer on that one is no solution. Yeah, so good enough on that one. Now, just as a reminder of these exceptions, if you ever get an isolated absolute value set equal to 0, then you're only going to have one solution. And if you get an isolated absolute value and it's equal to negative, then you're going to have no solution. So those are the two exceptions. Be on the lookout for those. But in general, we're going to solve it using these two cases, and I'm going to show you some example problems right now, and this is more typical of what you'd see on an assignment or on a test. So first thing we want to do is we want to isolate the absolute value. You'll notice that it's isolated already, so we're in good shape there. So I would really like you to do it in the order that I do it and show it where I show you to put these. So the first thing we're going to do is, it's isolated. We're going to remove the absolute value and we're just going to solve the equation. So I'm going to write x plus 4 equals 6. The other case, now don't solve this yet, the other case is we're going to remove the absolute value and we're going to set it equal to the opposite of that right there. Now, this isn't a big deal right now, but it is going to be a big deal down the road. The reason I put this one over here on the left and this one on the right, you might be able to think of why if you think back of the graphs that we did earlier. This represents the fact that we're going 6 units to the right. This represents the fact that we're going 6 units to the left. And if you put them that way, it's going to make it easier to solve some things that you'll do down the road in 9th grade and 10th grade where you solve absolute value inequalities and things that are a little bit more complicated. So just remember, the reason there are these two cases is because one is to the left when we get to negative 6 and one is to the right when we get to positive 6. So let's go ahead and solve this. I'm going to subtract 4 here. We're going to get x equals negative 10. Whoops. Write that correctly, negative 10. I'm going to subtract 4 here. Nice thing is we're solving both of these the same way, so we end up with a 2. So we get two completely different answers. If we plug both of those in, they would make the equation true. Let's just do this one really quickly. Let's plug in the 2. That's easy. 2 plus 4 is 6. Absolute value of 6 is 6. So that one would work. If we plug in a negative 10, negative 10 plus 4, that would be negative 6. So we'd have the absolute value of negative 6 equals 6. So that one checks out. And of course, on this one, we had absolute value of 6 equals 6. So that one checks out. So we're in good shape on both of those. Okay. All right, let's go ahead and take a look at this next one. This one is not isolated. So the first thing we're going to need to do is we're going to need to move that 7 to the other side. So I'm going to add 7 to each side. So now we've isolated this, and that equals 17. Now, once you have it isolated, that's when you can break it into the two cases. Do not break it into two cases, so don't make this a 10 over here and then a negative 10. We have to have this isolated first. So again, I'm going to take off the absolute value, set it equal to 17, and again I'm going to put that on the right. I'm going to take off the absolute value and I'm going to make that negative 17. I'm going to make that the opposite of what it was. And again, I'm putting it over here on the left because that represents going to the left, going on the negative side. So again, we're going to solve this, add 4. So we get m equals, this would be negative 13. So we'll go ahead and circle that answer. And then the other one, we're going to add 4 again. So those are going to cancel each other off, and we get m equals 21. So we get 13, and we get negative 13, and we get 21 here. Let's go ahead and take a look at this next one. You'll notice that the absolute value is already isolated. So I'm going to go ahead and remove the absolute value. I'm going to write the z over negative 9 on this side and set that equal to 2. Remove the absolute value. and set it equal to the opposite of this number. So that's going to be -2. And again, on both of these, I'm just going to multiply both sides by -9. So I get a z on this side, and I get a +18 here. And I'm going to multiply by -9 here, so I get a z equals positive times negative. This would be -18 here. Okay, so we did get two numbers that are the same. They're opposite signs. Those are the answers on this one. If you wanted to plug that in, you'd see that works out to make the equation true. But again, it's already isolated, so that's a pretty quick step. Same thing on this one. This one's pretty easy because it's isolated as well. So I'm going to write 3y equals 1. And then over on the left-hand side, because it was already isolated, I'm going to have 3y equals -1. And then, of course, we solve each one of these by dividing by 3. Can do all this work all the way across at the same time. So this is -1/3 for that one, and this one is +1/3. Okay. So we really want to rely on that method to solve these. So it's isolate the absolute value and then break it into the two cases. So let's take a look at this next one here. We're going to isolate this absolute value expression, so we're going to subtract 10. Those are going to go away. I get absolute value of n plus 5. Let's make that a little bit longer to make it look better, equals -8. Now, this is saying, when is the absolute value of n plus 5 equal to -8? Well, this is an absolute value. It's going to be positive. And remember, if you get it isolated and the other side is negative, there's no way these two things can equal each other. So we're going to write no solution. It's kind of nice when we get that. If you recognize that, we're done right there. We don't need to go any further than that. Let me just say this. I do have some people that will occasionally say, well, gosh, what if we did do this same method? What if we broke it into two cases, made one of them the opposite number and stuff like that? We could do the same thing here. The problem is, if you try and plug that in, it's still not going to make the equation true. So you would get a positive number on this side equaling a negative number on that side. We just can't make that equation true, no matter how hard we try, no matter what number we pick. That's why there's no solution. Okay, and then of course we've got this last part right here. It's not isolated, so let's go ahead and isolate it. I'm going to subtract 9 from both sides. That's going to give me the absolute value of p is equal to 0. Again, the only way for the absolute value of a number to be 0 is if it's right on top of 0. So even if I tried doing this, remove the absolute value, solve that, remove the absolute value, there's no such thing as -0. These are the same thing. So the answer on this one is p equals 0. We only get that one solution. Okay? All right, last little bit here, just a couple notes to remind ourselves of. The answers are not just opposites of each other. There are some people that kind of get lulled to sleep and they think, oh, well, gosh, I did this and I got 18 on one, so the other one's got to be -18, or I got 1/3 on one, the other one's got to be -1/3. That is not the case. It does happen occasionally, but you don't rely on that. So please don't get an answer of 5 and just say, oh, the other one's automatically -5. That is not always going to happen. In fact, most of the time it's not. And then the last thing I want you to keep track of is this. It's okay to have a negative answer as long as that answer makes the equation true. You'll notice that we got several negative answers as we went through and solved these. If we plug those in, they would make the equation true. And again, that's the point of solving equations. All right, good luck with the assignment.